let's talk about how to write a recursive equation for a sequence that has a pattern. Here we have a sequence, and again, if I wanted to use my notation, I could call that a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, dot, 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 and some unknown term I could call a sub n. After that, I could call it a sub n plus 1, and on and on. How could I write a recursive equation that would generate this sequence? Well, step one, you always have to give a starting value. So I'm going to say, I'm telling the world that my first term is 3. And then I have to tell the world what the pattern is. Well, let's look and see what the pattern is in this sequence. Let's see, 3 becomes a 7, 7 becomes an 11, 11 becomes a 15. Ooh, are you seeing what I'm seeing? I'm seeing a plus 4, a plus 4, a plus 4, a plus 4. Yeah, this is an arithmetic sequence. So basically, what I want to do is I want to tell the world that I'm adding 4 to the previous term. To get the next term. Okay? Now, this doesn't look very mathy. So how can I say that in a mathy way? Well, the next term I can think of as some unknown term. Well, let's look at our unknown terms. A sub n is an unknown term. What's the term before it? Oh, maybe a sub n minus 1. So I could write this as, to find a sub n, take the term before it and add 4. So this, together with this, would be my recursive equation that would generate that sequence. Now, that's not the only way I could do it. I could have also said my first term is 3. And I could say, hey, I could say a sub n plus 1. How do I find a sub n plus 1? Well, I take the term before it, which is a sub n, and I add 4. So I could do it that way. There's an infinite number of ways you could write these recursive equations. But you have to give one of the terms. We often give the first term. And then you have to tell us what the pattern is and how to use the previous term or terms to get the next term. Let's look at another example. Here's a sequence. Let's see if there's a pattern. 2, 20, 200, 2000. Ooh, what am I doing? Yeah, I'm multiplying by 10. Times 10, times 10, times 10. This is a geometric sequence. Let's write a recursive equation for it. Well, I can say that my first term is 2. And to find any term, what am I doing to the previous term? I'm multiplying it times 10. So what notation can I use to say a previous term? Well, again, we have some flexibility. But if I want to find the nth term, then I take the term before the nth term, which is the a sub n minus 1, and multiply it by 10. That's kind of cool. Is that the only way to write this equation? Heck no. If I felt like it, I could say the first term was 2. I could say a sub n plus 1. To get that term, I take the term before it, which is a sub n, and I multiply that by 10. Or heck, I could even, if I wanted to, I could even give the second term if I felt like it, right? You just have to give some term. And I could really go crazy and say, hey, to find the a sub n plus tooth, I like saying tooth, term, it's going to be the term before that, which is a sub 1 times 10. Lots of different ways you could write a recursive equation for this sequence. This is a tricky sequence. There is a pattern, but it's not geometric and it's not arithmetic. This is a bit challenging. See if you can figure out what the pattern is. See if you can figure out how would a 1 become a 3, and the same thing would turn a 3 into a 7, and the same thing would turn a 7 into a 15, and the same thing would turn a 15 into a 31. Gosh, let's experiment. I mean, just this 15 and that 31. If I double 15, that's 30. And if I add 1, that's 31. Let's see. If I double 7, that's 14. Ooh, plus 1. If I double 3, that's 6. Oh my gosh. So it looks like I'm doubling the previous number and adding 1. So let's write our rule. My first term is 1. And then what I'm doing to get the next term, I'm just going to write it out in English, is doubling the previous term, the term right before it, and then adding 1. Okay, so how do I write that? Well, let's just call my term that I want to find a sub n. It's up to you what you call that. So I'm doubling the term before that. The term before that would be a sub n minus 1. So I'm going to double it. So I'm multiplying it times 2. And then I'm adding 1. How cool. Let's see if this works. So my first term is 1. Then I put a 1 in. 2 times 1 is 2. 2 plus 1 is 3. So far, so good. I put a 3 in. 3 times 2 is 6, plus 1 is 7. I put a 7 in. 2 times 7 is 14, plus 1 is 15. That works. So you see, these recursive equations can get tricky. But again, they're kind of like puzzles.